Hello, this is Dustin Burrell with CIS Networking 104 class. We're on chapter 12 now, which is Hands-on Lab 12.1. We're working with the standard IP access list. As you can see, this is the network of the configuration. I pretty much did step by step of configuring my PC with this IP address, this PC with this IP address. Here's my configurations for the G interface and S interface. So it's all running through, and right now I'm at the point where I can only ping from here to here successfully. Let's see why that one failed. Huh. Let's see something else here. Go from here to here. PC1 has no functional ports. I will have to pause the video and fix that real quick. And while you guys are getting ready for this video, you might as well configure your network with all the correct IP addresses and IP configurations for your PC so we can have successful pinging. I'll be right back. Alright, that was a pretty easy fix. I just had to make sure that I did my configurations correctly. I didn't have anything in here. That's why I didn't have any functional ports. If you guys are wondering what the DNS server will be, actually I need to switch that to 127. Show it off a little here. 127 gateway. And then I use these addresses for the G interface, serial interface, O1. This one is actually only serial face 1, so let's fix that real quick. Not a big deal, but better to just get it correct. Actually, no, wait, this is the 0. I'm sorry, I apologize. Okay, alright, so my network's ready. We're just ready to start the 12.1 standard IP access list. And as I was saying, let's see if we can ping correctly now. Good. We should not be able to ping from here to the corp yet because we haven't done any routing configurations to be able to go through multiple devices right now. Don't really know why that failed. Okay. That's good. That's good. Looks like I have one more configuration I need to get done. Right here to here. It's not working. Let's delete all that for a second. Go from here to here. Okay, hold on. Be right back, guys. Just a sec. Alright, I'm back. I was just trying to configure why I was getting failed PDUs. Like, I'm pinging successfully everywhere, but from here to here, there's a configuration problem there. But we're just going to move on and get this video rolling just so I can actually get it done and get it going. So basically, on the first step of Hands-on Lab 12.1 Standard IP Access List, in this lab you will allow only packets from a single host on the San Francisco local area network to enter the LA local area network. Go to the LA router and enter global configuration mode, which I'm already in. Hold on, I'm going to start all over. Comp T, we're in configuration mode. From global configuration mode, type access list with a question mark to see what there is there. You will get a list. Choose an access list number that allow you to create an IP standard access list. This is a number between 1 and 99 or 1300 and 1399. Choose to permit 192. We're going to go with access list. Choose to permit the 192.168.10 LA.2 host, which is the host address. So it's going to look like LA config access list 10 192.168.20.2 and then question mark. To specify only host 192.168.20.2, you must use the wildcard 0000. But first we need to permit the 10 section. So just a second here. Let's go 10.2 with a wildcard of 0.0.0.0. Invalid input. Access list 10. Oh, I forgot to put permit in there. Access 10. Access list 10. Permit 192.168.10.2. There we go. So that will access that permit list. And then we choose to permit the 192.168.10.2, which is that host address we just did. Then do the same thing with the 20 mask also. So access list. This time it's going to be 10 permit, but 192.168.20.2 with the wildcard mask 0000. Now that the access list is created, you must apply it into an interface and make it work. So we're going to stay in the LA router. We're just going to go to interface G0/0. And inside here, we're going to go IP access group 10 out. And after we put that command in, that's going to pretty much allow us to group those two access lists together and be available for our routing configurations throughout this network. Now you got to verify your access list with the following commands. These are pretty easy. We'll just exit out of here and just do it. Show access list. And right there it shows the ones we just permitted right there. Standard IP access list. Permit 192.168.20.1. And then do a show run. Show, come on. There we go. Show run. And here we're looking for interface IP address, pretty much under our gigabyte right there. IP access group 10 out. It did apply with the command. Test your access list by pinging 192.168.10.1.2 to 192.168.20.2. So that would be, well, we'll try it on here. I don't prefer doing it here, but this is fine. Ping. We're in, hold on, I gotta make sure I'm in my right network. We're pinging from 192.10, which I'm in right now. We're gonna ping 192.168.20.2. Sex rate is 100%, so it is doing it perfectly. That's good. We could even come over here and go bam, bam, see if we're good. We're good. Here, so here's the one I'm worried about. And I still am missing a configuration somewhere, but let's see if we can at least go from here to here now. No, we can't. Okay. So if you have another host on the LA local area network, ping that address, which should fail if your ACL is working. So yeah, let's try that. Let's try the ping again. Let's go ping. We did the 20.2. Let's actually, I don't think I have another. Well, we'll try pinging the 17. We'll try pinging 192.168.10.2. There really isn't another one to ping, I don't think. We'll try to ping this one down here. Echoes. We got an echo request. Okay. And see, something's up with the configurations. I thought I set everything up right. Probably missing one little thing, but I don't even know if that's necessarily another network. I think if we had another 192.3.0, we could do that, but it's gonna fail because we don't even have that network set up. Okay, so next we gotta move on to Hands-on Lab 12.2 extended IP access list. In this list, you will use an extended IP list to stop host 192.168.10.2 from creating a telnet session to router LA 172.16.10.6. However, the host should be able to ping the LA router. IP extended list should be placed close to the source. To add the extended list on router San Francisco, pay attention to the log command used in step 6. It is a Cisco objective. Step 1, we're going to remove any access list on San Francisco and add an extended list. So choose a number to create an extended IP list. The IP extended list uses 100 through 199 or 2000 or 2699. Okay, so use a deny statement. You'll add a permit statement in step 7 to allow other traffic to still work. So what we want to do is go back into our San Francisco router here. Configuration mode. And on configuration mode, we're basically just going to give an access list 110 deny. Access list. Oh, I forgot the question mark. Alright, and you'll see that authentication header protocol pulls up. Gives you the numbers. Gives you the commands of ICMP. Pretty much shows you everything that you're denying right there. Since you are going to deny Telnet, you must choose TCP as a transport layer protocol. So the next command you'd want to put in is deny TCP question mark. ABCD source address, any source host, and a single source host. They're all going to be denied by TCP after this command. Add the source IP address you want the filter on, then add the destination host IP address, and use that host command instead of the wildcard bits. So basically, after access list deny TCP host, hold on a sec. Access list. Oh, yeah, you gotta go TP host 192.168.10.2 host 172.16.10.6 question mark. Oops. After that, there's going to be many things that pull up here. ACK, match on ACK bit, starts with AHP for me. It shows all the commands. Here actually starts with DSCP for me, which is matching on established connect. Match packets with given DSCP value, match only packets on given port number. It's setting up the rules basically with that command. At this point, you can add the EQ telnet command to filter host 192.168.10.2 from telnetting to 172.1610.6. The log command can also be used at the end of the command, so that's whenever the access line is hit. The log will be generated on the console. Let's do another command real quick to help us out with telnetting. Okay, so to do the telnet, we're going to do accessed list 110 deny TCP host 192.168.10.2 host 172.16.10.6 EQ telnet log. And hold on a sec, we'll see. Might have did something wrong there. Access list 110 deny TCP host 192.168.102 host 172.16.10.6 EQ telnet log. That looks pretty right to me. Hold on. Okay, just a second here. Oh, there it is. Need another C. Accessed list. Okay, let's try this. Alright. At this point, you can add the EQ telnet command to filter host 192.168.10.2 from telnetting to 172.16.10.6. The log command can also be used at the end of the command so that whenever the access list line is hit, a log will be generated on console. So we're in San Francisco config ACCESS list 110 deny TCP host 192.168.10.2 but host 172.16.10.6 EQ telnet log. It is important to add this line next to create a permit statement. Remember that 0000 255 255 255 255 is the same as any command. Hold on just a second here. Why the heck? Oh, I think I need to do a question mark at the end like I do. Unrecognized command. Okay. Deny TCP host 192.168. See what happens when I do one. Thinking it might be reading the wrong network. No, that's not it. Okay, I can't get this command to work, and I seem to be typing it in. Access list 110 deny TCP host 192.168.10.2 is what we want to deny, but we do want to host 172.16.10.6 EQ telnet log. And I am in configuration mode. There should be no reason this isn't working. So I apologize. I'm just going to move on to the next step. So as I said, it's important to add this line next to create a permit statement. Remember 0000 is the same as 255 4 times is the same as any command. So this time we're going to want to go access list 110 permit any permit IP any 0.0.0.0. This command is going to allow all the addresses to be able to go through. And it took it just fine. You must cremate a permit statement if you just add a deny statement. Nothing will be permitted at all. Please see the sections earlier in this chapter for more detailed information on the deny any command implied at the end of every ACL. So basically now we're on step 8. Apply the access list to the fast Ethernet 00 on San Francisco router to stop the telnet traffic as soon as it hits the first router. And the way we're going to do that is go interface G0/0. Because I'm G, he's F in the book. And we go IP access group 110 in. That means we just put that group in. Now try telnetting from host 192.168.10.2 to LA using the destination IP address of 172.16.10. This should fail, but the ping command should work. Okay. I was expecting it to fail anyway, just because I'm having issues with my S001 cable over there. Okay, what we're doing here, ping. Try telnetting from 192. Actually, I should say telnet. Telnet to 172. 172.16.10.6. And like I said, it should fail, but the ping command should work. Connection timed out, remote host not responding. Let's just try to ping it. Okay, ping's working. Telnet worked, but it timed out. Now on the console is SF because of the log command output should appear success rate 00. With these commands such as IP access log GP, I didn't get that kind of error. But basically, I have taught you guys how to use these commands. There's just some troubleshooting to do to get this correct. But I think you guys understand the basics. If you have any questions or comments to ask me of any confusion on this, I can clear it up for you and I'll answer back in a timely fashion. But thank you for joining me on my video. That's all I got for you tonight. Have a good day.